Hello and welcome to today's webcast titled Fueling Efficiency, Implementing an Economical and Fast Heat Rate Reduction Solution. I'm Aaron Larson, Executive Editor of Power Magazine, and today I'll be joined by Janet Webb, Senior Digital Product Manager for APM Reliability and Performance Suite with GE Vernova, and also Aisha Murtaza, Technical Project Manager for APM Reliability and Performance Suite with GE Vernova. To begin, Janet, can you tell a little bit about yourself and what you do in your position?
Thank you, Aaron. Hi, I'm Janet Webb. I am the lead product manager for our APM reliability and performance software. That includes Performance Intelligence, which is the product that we'll be focusing on today. I've been with GE for 17 years, just the last couple in this digital software space. And prior to that, in power generation, primarily focused in reliability engineering. And I am located in Virginia, about a 4-hour drive from Washington, D.C. Thanks, Aaron.
All right. Well, thanks, Janet. And Aisha, I'd also like to have you tell a little bit about your background and explain what you do with GE.
Thanks, Aaron. Hello, everyone. Thank you for joining us here today. I'm Aisha, and I started my professional career 7 years ago with GE as a power plant performance engineer. During my time on site, I also gained a lot of valuable experience when it comes to equipment reliability and maintenance. Fast forward to my current role, I lead the implementation of APM Performance Intelligence and Reliability Plus here in the Middle East region mostly. Leveraging my experience on the field and using GE's digital solutions, I do my best to help our customers in optimizing their operations and day-to-day power plant performance. I'm very excited to be here today to talk to everyone about all the cool and incredible features of performance intelligence that it brings to the table when it comes to monitoring and heat rate optimization.
All right, thanks, Aisha, and I'm looking forward to the discussion that we're going to have with both of you. Thanks for both of you being here. So today's presentation is expected to last about 30 to 40 minutes, and it will be followed by a Q&A session, which should. And before we begin, I'd like to run through a few housekeeping items. In the webinar platform, you should see a chat area and a Q&A area. If you're experiencing any technical difficulty, you can ask for help using the chat function, and our production staff will assist you. To submit questions for our speakers, please enter those in the Q&A section rather than in the chat area. You can enter questions at any time during the presentation, and we'll answer as many as possible during the Q&A section at the end. Any that we don't get to during the live session will be answered via email after the webinar. Today's presentation will be archived on our server for up to 1 year, and future viewing will remain free of charge. You can use the same URL to reach the archive program as you did to reach the live program. The PowerPoint slides and handouts will be available for download from that web page after the presentation. A certificate of completion for professional development hours will be sent via email to every registered participant who attends. Before we begin, I'd like to thank GE Vernova for underwriting today's program. The company's generosity allows everyone to attend the presentation at no cost. And with that, I'd like to kind of tee things up with a little background. I'm sure most of our audience realizes how important heat rate is for a thermal power plant. It's critical in maintaining a competitive position in the market. Heat rate is a very important aspect of all of the cost, the overall cost for power generation. It often accounts for anywhere from 60 to 80% of variable costs for a power plant, and even small improvements in heat rate can have a major impact on plant financials. The adoption of predictive and diagnostic software offers power generators the opportunity to more easily achieve improved heat rate while significantly reducing fuel consumption. And by reducing fuel, it often improves your CO2 emissions. They inherently go down with less fuel used, thus helping to attain emission reduction targets. So to kick things off, and before we really dive into the technology, Aisha, could you tell a little bit about what you've seen happening in the past 10 years and how it's impacted the way power generators think about heat rate?
Yep, absolutely. So I think over the last 10 years, I'm sure we can all agree that we've seen sort of a shift or a change in market dynamics, mostly driven by fluctuating fuel prices and the government regulations when it comes to emissions. And this has caused a lot of the power generators to adapt to these changes and operate their plants with a lot more flexibility, which is, as we can all understand, it's not very easy, and it requires a deep understanding of heat rate dynamics to get the best economic returns. Uh, in addition to that, I think there's also been a lot of growth, in the renewable energy sources like wind and solar. And what that has done is it has added a lot of variability to the grid. And once again, the traditional power plants, they've had to adapt to these changes, and optimize their heat rate more so than ever in order to, efficiently ramp their generation up and down as needed. What do you think, Janet? I'm sure you have something interesting to add here.
Yeah, I totally agree. I think we are seeing more than ever, power plants are interested in improving heat rate, maintaining heat rate. So one of the things that we've been able to do with the software, with Performance Intelligence, is add the ability to have accuracy during part load operation and potentially find performance issues during part load. And so, for example, you could have someone who says, I'm going to run at 85% of full load. We have the advanced modeling capability now to provide that accuracy where you will see if you have a performance issue. Whereas in the past, it's easy to miss at part load because you're still able to make power. You don't necessarily realize that you're using extra fuel to do so. And so we've actually had a customer who was operating at part load through the shoulder season, worked with us on that modeling and detected multiple issues, opportunities for efficiency improvements that they were able to address before peak season and before being called to full load, where they would have come up with a 10 megawatt shortfall. So really significant. And the factors were compressor fouling, combustion tuning, things that are common in thermal performance, but that they wouldn't have had the visibility to without having the software tool.
All right. Thanks to both of you. And at this point, we've got a couple of poll questions loaded, and I'd like to roll out the first one to see what our audience is struggling with, particularly what is your biggest heat rate concern? And we've got three options there listed. Is it fuel cost or carbon emissions or outage potential? So just take a moment and kind of give us what your biggest heat rate concern is. And we'll wait just a few seconds for these to come in. Looking at the results, it looks like about half are worried about or have their biggest concern as fuel costs. So fuel costs followed by carbon emissions and then outage potential. So not surprising. And Aisha, you mentioned about data analytics. How has data availability changed the way teams are running heat rate?
Yeah, I think we can all agree that availability of data has been a game changer in all industries, really. And speaking specific to power generation, with advances in sensor technology, well instrumented, modern equipment, uh, advanced data collection systems, the ease of deploying, accessing applications on the cloud. uh, I think we've essentially gained superpowers, right? I mean, you can now keep a real time eye on the operations and performance of your plant. You don't have to be physically present on site. You can be, thousands of miles away at a corporate head office, or even in a different country, like I do. I'm not really on the sites, but I can help customers uh, with their operations just by simply monitoring their day-to-day operations and performance, thanks to solutions like performance intelligence. In addition to that, the availability of data has also opened the world of predictive possibilities. Through machine learning and data analytics, you can now foresee equipment failures in advance, and also equipment issues that can mess up with your heat rate goals, right? Janet, what about you? Do you have anything to add again?
Yeah, I would build off of that to say, in addition to having these improved analytics, better detection, performance intelligence takes it a step further by adding automated alerts to that with recommended actions. So when there's a potential performance issue, you're receiving an alert and it's telling you where to look, to walk through kind of how that works. The models that are developed are tuned to your equipment design and then validated with the as running data. So you've got entitlement where you should be performing. And as I mentioned, that could be full load or a part load. And then when there's a difference between your expected performance and the calculated performance, you receive an alert that comes with the recommendation and really helps get to the root cause faster. So it's more visibility, but also a productivity enhancement.
Yeah. And Janet, you mentioned performance intelligence, and I know the definition of that is it's a thermal performance monitoring tool that enables power teams to make a noticeable impact on their heat rate. How does PI actually?
That's a great question, and one of the most common ones that pop up during our discussions with the customer during implementation. And I think what's important to understand here is that at the core of performance intelligence are these very powerful physics-based models, like and like Janet mentioned, they are developed using your plant's design data. They're tuned to your specific configuration. They're running continuously in the background at the back end, uh, calculating performance KPIs using the live sensor values, which are once again coming from your plant. So this all is happening at the back end. Now, through the different features and applications of the front end software, performance intelligence, you have the power to access both summarized insights as well as dive deep into the detailed analytics of your power plant's performance, right? So you can use all of this information, conduct weekly, monthly, quarterly reviews to really keep an eye on how your plant is performing. So essentially, you're not just staying informed, but you're also actively strategizing, right? So if you're aware of the issues, you can plan proactively all the maintenance actions that can be channeled to where they're needed mostly to optimize heat rate and operate efficiently.
And what level of information can users get from this? Is it heat rate at a plant level or more insights at the assets level?
Yeah, anytime anyone asks me this question, I just tell them it's like having performance intelligence is like having a microscope for your plant. So with performance intelligence, you get a magnifying glass on critical KPIs. So you have visibility at fleet level, all those matrices like power generation, heat rate, fuel consumption, and you can go all the way down to equipment performance parameters. So we're talking turbine efficiency, heat exchanger effectiveness. For some of the assets, we also provide sectional KPIs like steam turbine, HP, LP, IP, efficiency, steam flows, which can help you in really, knowing where the issue is. So it's just all about giving you the power to spot the issues and, fix them promptly as well.
All right, very interesting. Thanks, Aisha. And at this point, let's roll out poll question number 2. And in this question, it's, do you use an in-house method or technology for heat rate management? Simple yes or no. Are you guys in the audience using this type of technology? And kind of wait for a few answers here to come in and see where our audience stands. Initial results are about a 60-40 split, with 60% saying yes. And it seems to be hanging right around those levels, 60-40, 60% yes. So still a lot of people still not using this technology, which, I think opens up a lot of opportunity for people to improve their heat rates if they do start. So why is software needed to reduce heat rate? How does that work, Janet? Can you give a little more background on that?
Yeah, I think there's a couple of great opportunities. First would be if you have heat rate improvement goals and capacity improvement goals, and you don't have, the CapEx for a big hardware upgrade, or potentially that's in the plans, but, it could be years down the road. Software is a much smaller investment to start to see those improvements in heat rate. But even, I would say, for our customers who have, in some cases, done a hardware upgrade, they are leveraging performance intelligence to operationalize that heat rate management in an ongoing process, so that, maintaining and not having missed opportunities that they don't have visibility to. You could have a leaking valve at any time in operation. And, it might be a couple of megawatts, but as you find a couple of these different opportunities, it really adds up. We had a customer who didn't realize that they weren't using the best temperature for their chiller, for, initiating use of their chiller, as they had made other changes around the plant over time. And this was a case where it was a GE person who is monitoring their thermal performance with performance intelligence, but was able to notify them that even though it was just a few degrees off, that this was really a significant impact of when they should be initializing that use of the chiller versus not.
Yeah, that's great insight, and kind of answers my next question, which in the title it says that this is a fast and economical solution in improving the heat rate. And from everything we've talked about so far, it kind of comes down to visibility and data that improves productivity. So is there anything you can expand on from that, Aisha?
Yep, absolutely, Aaron. So it really does boil down to, the importance of visibility and how data can be leveraged to gain valuable insights. And let's talk about a couple of features of performance intelligence itself, and how, that same visibility can help you in gaining valuable insights. So the performance dashboard of performance intelligence is like your performance summary hub, right? It provides you with all the performance summaries of all the covered equipment at different operating conditions, ensuring that you are consistently monitoring performance throughout your plant. This will be, like a high level summary, like I said. Now, if you want to dive a little bit deeper into what exactly are your equipment doing, the thermal performance feature uh, provides you with valuable insights into equipment degradation trends over a period of time. And it shows you how your equipment has been performing, or the performance, has evolved over a period of time. Uh, to put a cherry on top, you have some predefined set of trends that highlight the equipment with the most significant impact on heat rate. And all of this information combined is essentially your key to promptly identify the issues and channel your maintenance efforts where they're needed the most. So I know that was a lot of theory. So if I give you a practical example, right? So let's say the condenser is showing the highest level of degradation at your plant. Uh, your performance engineer can deep dive into factors like condensers, inlet and outlet conditions, its effectiveness, uh, vacuum levels, to gather data-driven insights all through performance intelligence. This way, your maintenance team can proactively plan to inspect the condenser, looking for potential leakages or scaling issues, and take the necessary actions during the scheduled downtime.
Yeah, that's a great example. And so how does performance intelligence fit into existing strategies and improve upon them in some ways?
Yeah, so performance intelligence has assisted a lot of our customers in transitioning towards a condition-based maintenance approach. I remember one of our customers, they were following a very traditional maintenance strategy, uh, performing offline water wash only during planned outages, without considering the actual extent of the compressor fouling. Uh, and here's where performance intelligence, really came into the picture. We deployed the offline water wash advisor, and it recommended an earlier wash based on the level of compressor fouling. Now, during the post-deployment phase, we encouraged our customer to go ahead with the water wash as suggested by the tool. And to our satisfaction and delight, we immediately noticed recovery both in terms of heat rate and megawatt, perfectly aligning with the predictive outcomes from the water wash advisor. Janet, do you have anything to add here?
Yeah, there's an interesting case that we saw as well this summer in North America related to the wildfires in Canada. I'm sure many of you know that covered a very wide geographical area. And so our power plant operators saw an impact on their performance while they were ingesting smoke, as a result of the smoke, but also increased compressor fouling. And so we have a customer in affected in this region who saw that they had an earlier recommendation to do the offline water wash than they would have expected, and certainly earlier than a time-based interval. So that was very insightful. We also have heard from customers that they're regularly scheduling the water wash, and it's sort of the flip side of this, where they're doing it very frequently to make sure that they don't have a lot of degradation, but it's potentially too frequent in terms of being economically optimized. And so this is actually, we were speaking recently to a potential customer who's interested in learning more about PI and considering implementing it. And their comment was, we think this is going to tell us when we can do this less frequently. In the US, this is call it roughly a $50,000 maintenance event. And so if you can eliminate one in a year, that's a pretty significant impact.
Yeah, that can be very important. So many utilities have been streamlining their workforces due to budget constraints, and some have been losing, long-time employees due to the just aging and retiring at high rates. So how can the heat rate best be managed in these cases where you've got new employees or fewer employees behind the scenes?
Yeah, I would say it's common to have a performance engineer who monitors multiple sites across a fleet. And so they can't really have eyes on all the equipment 24 hours a day, 7 days a week, but software can. It's where this, alerting capability can really bring the issue to someone's attention quickly if they're focused at one site and an issue comes up on another site that maybe they wouldn't see, and a week could go by. They're getting the alert that tells them that that's where they should shift their attention. We see this with our predictive analytics as well in terms of reliability, availability software. The power generators are facing more complexity than ever before with multiple generation types and the flexible operation that goes along with that, et cetera. But they aren't often getting more resources to manage that complexity. And so automation and software in general has really a lot of power to help navigate through that. Aisha, anything that you would add?
Yeah, I think apart from, real-time monitoring, as you've mentioned, I think it can really help in allocating resources when it comes to maintenance outages, planned or unplanned. Like I mentioned, the thermal performance tool will really help you in identifying, the bad actor or the asset that has to be prioritized during outage, so you can, really manage your resources very well during outages as well.
Great point. So at this point, we've got our third poll question. Let's roll that out. Question is, do you manage thermal performance via an M&D center, monitoring and diagnostic center, for those that may not know the term, by individual plant, or don't currently have anyone looking at thermal performance? So how are you monitoring thermal performance? Wait for these results to come in a little bit. Looks like a fairly even split between those that do it with an M&D center and those that do it by individual plant. Actually, individual plant has moved up the list now. It's about 50% are doing it at the plant level. About 30% at M&D centers, and about 20% aren't doing it at this point. So that's, again, an opportunity for some people to really make some improvements that could benefit their heat rate. So we've talked about how important this can be for different plants, and it seems as if it would be great for everyone, anyone that could do this. But are there candidates that maybe that wouldn't be good for utilizing this software?
Yeah, it's, I would say there are cases where we have not recommended performance intelligence after looking at the potential for value. So an example, because the value is so closely tied to the improved fuel savings and increased capacity based on improving efficiency, if it's a single peaking site, there's maybe not a lot of opportunity there to get that return on investment in terms of fuel savings. But I will say that where we have, for example, one customer with a fleet that includes multiple peaking sites, they are leveraging performance intelligence to understand best and worst actors. Which unit would you bring online in peak demand? Where would you prioritize maintenance? That kind of thing. So there is some value there. And then the other instance that I would note is for utility customers where they're not directly impacted by that fuel cost. There's less interest and maybe less opportunity for value. But again, with exceptions to every rule, we do have utility customers who are using PI to do that kind of due diligence to maintain a low heat rate and pass on as little cost as possible to an end customer. So I would say to all of you joining us that if you think this is potentially a good solution, please do connect with us, and we can go through that investigation with you and help determine, is there a good value story? This is where our solution architects and our subject matter experts like Aisha can really help work through that with you. And I would say broadly, we have a software suite across APM and beyond that we offer from GE Vernova. That the goal of our solution architects is to really understand your specific pain points and what software is going to add the most value. And from an adoption perspective, we see a lot of success with, starting with the biggest area of concern, maybe just at one site, realizing that value, and then taking the step to, does this apply at other sites, or are there then other products in the portfolio that would take care of kind of the next biggest concern? So I think that's the adoption process that we see a lot of people use and really get a lot of value from.
Yeah, it seems like just dipping your toe in the water would be a good way to get you on the right path. So one of the barriers, that I've heard from people in the industry to buying these types of software solutions is that they have a feeling that it's going to take a long time to deploy, and that once it is deployed, maybe the employees aren't going to embrace it the way they expect them to and utilize it to the best of its abilities. So how do you address those type of issues with performance intelligence?
It is about a 6-month deployment. It's partly due to these detailed advanced models that are built specific to your equipment. It's not just as easy as clicking the download button, unfortunately. But it's a process that our services team leads and connects as needed with your IT or engineering team to have connectivity to the site. So in the case of a cloud solution, this is a little bit different than if it's an on-premise solution with hardware at the site. In that case, we can either connect where there is connectivity allowed, but in certain regions where that's not an option, we can also fully configure the software and deliver it on a server. But it's something that our services team will take you through. So it's not a lot of touch time on your end, even though it's a 6-month process overall. The other thing I want to note here is the change management process that I think we've touched on a little bit. That we see the most success when there's a plan to adopt the software and navigating through that change with the whole team that's done very intentionally. So as the plant manager, setting expectations, letting the team of users know that you support them, that can be incredibly beneficial. And then as the engineer or the end user, making sure that you're really carving out the time to adopt something new, and reaching out and working with GE if you get stuck in any way. So it's having everyone on board with the overall benefit and business benefit, as well as productivity and visibility benefits. I've got a quick anecdote here. I was in a conference this summer in Atlanta, Georgia, a users conference, and after all the technical sessions, we were sitting in kind of the networking opportunity with some friends who run a power plant in North America, and they were noting one of their colleagues who wasn't there, but who had been at the plant, for something like 40 years. And they were doing this very affectionately, but they were saying, how, so-and-so doesn't want anything new, totally resistant to any new process, new tool, etc., until he sees the value. And then he becomes the biggest cheerleader, the biggest advocate, telling everyone about, you've got to use this new thing. And I just appreciated it so much because I was like, you're telling the journey of software adoption, like you're telling the story, and totally provoked, or we weren't talking about software specifically, so appreciated that.
Yeah, Aisha, do you have anything to add on this topic?
Yeah. So as Janet mentioned, the implementation cycle can take up to 6 months, and again, as she's mentioned, it's because our approach, it relies on physics-based models, which are anything but one size fits all, right? So we use the plant's heat mass balances and the design data sheets amongst all the other design information available, which is collected as part of our site surveys when the project is kicked off, and the models are very customized to your specific configuration and operations. When these models are developed, they go through a very exhaustive cycle of validation at different operating loads, right? Whatever is the range of operation, and we go through this thorough exercise to make sure that the results which are coming out of these models, those are the baseline, really. They're very accurate and robust. In terms of change management, which is a very important aspect for all our customers, and we spend a lot of time discussing this with our customers, and our adoption journey really begins at that kickoff meeting with you, right? And I say this because the implementation team, the subject matter experts, the data integration team, they work side by side with you throughout the implementation process, throughout the model development and model validation phases as well. And we do this proactively so that you are very comfortable with the results which are coming out of the models, because it's not really, like I mentioned, not a one size fits all, and we need a lot of tuning to make sure that we get the best possible results out of these models. During implementation, we also conduct performance intelligence awareness sessions, so that you are very comfortable with the different features, the different tools of the software itself, so that when the solution is deployed, there are no surprises, just seamless adoption. And when it comes to our enterprise customers, we go one step further and we conduct these awareness sessions with each side, because we really want every member in your team to be familiar with the software, to use it, so that they don't just log in once a month, but it becomes a part of their day-to-day activities. Apart from these awareness sessions, once the solution is live, we also have dedicated training sessions, which are once again led by our subject matter experts, so that you're very, very, so that you yourself become an expert when it comes to using the software. After deployment, after training, you don't have to worry. We're not going to go anywhere. There's also a post-deployment support phase where we keep regular communication with our customers to answer any questions they have, to really help them in getting valuable insights from the software. So our goal is not just to deploy the software. It's not just a one-time solution. I think it's a partnership between GE and their customers. It's a journey, and we really want you to know why you're clicking that button, or why are you going to this feature rather than just click this button and this is how you navigate to different parts of the software.
Yeah, I think that customer support is a really important piece of that puzzle. So how does this performance intelligence integrate with other GE Vernova digital software?
It's in our asset performance management suite of products. So some of you may remember that previously this was under operations performance management, OPM, and we've recently last year migrated into APM because of the synergies that we see with reliability and with other products for our customers who have a broader solution set. But as an example, when you get an alert in PI, it's in the same alert screen as your Smart Signal or Reliability Plus alerts. They both leverage what we call blueprints, and all of that navigation is the same. Now you can also see that alert in a dashboard view, but as you navigate the software, if you want to see that full list together, you can. It works the same way in terms of creating a case from an alert where you want to take further action and you want to go through that workflow with the right individuals connected and documenting through that process. So it's all integrated together. The other thing that I'll mention is the summary dashboard that Aisha has been referring to is configurable by whoever you choose to have that admin level access in the software. So even after it's fully delivered, if the person using it wants to see something differently, those changes can be made. And that's part of the, making that type of change is part of the training that Aisha is referring to.
Yeah, very interesting that you have that capability after the fact. Now, some people in the audience may be asking, I've got a performance guarantee in a customer service contract. Do I really need a thermal performance tool? How would you answer that?
Yeah, I would say in some cases, no. We have customers who, as I mentioned before, utilities in particular, who are less impacted by a fuel cost, and they believe that their performance guarantee meets their goals, and so that in some cases is enough. If you have that agreement and you are someone who's wanting to maintain a low heat rate, improve fuel savings, there's, I think, a lot of opportunity beyond the guarantee, which really says, on some periodic rhythm, there's going to be a performance test. If if the equipment falls short, and often this is just the gas turbine, not at the plant level, then there will be liquidated damages paid for that shortfall. It doesn't, in that case, tell you where the issues might be, and it doesn't give you those insights over time to get back the 2, 3, and 5 megawatts that we've been talking about. So maybe you still meet the guarantee, but there really could have been a lot more fuel savings in the interim.
Yeah. So what really makes this performance intelligence tool unique? Is there anything that you can point to?
Yeah, I think one of the primary factors that sets performance intelligence apart is our modeling approach, which I've highlighted previously as well. These are powerful thermodynamic models. They are developed, using plant-specific design information like heat mass balances, design data sheets, performance curves, performance test reports, and we spend a lot of time and effort in validating these models thoroughly, so that they genuinely represent a digital replica of your plant. And the other thing I think which makes this software unique is the active engagement of SMEs throughout the implementation. So from the time of kickoff, conducting awareness sessions, conducting PI trainings, and then also supporting post-deployment. We really feel that this is something that makes this software unique. You're getting, on-the-go recommendations. We're encouraging customers on following the suggestions provided by the tool. And I think this kind of engagement from an industrial SME is missing in other products.
Yeah, I think that hand holding can really be important to making a successful transition. So what does the roadmap look like? What are your plans for performance intelligence?
We have a feature that just came out this year, and I'll call it a beta version at the moment. We haven't released this to all customers, but it's all about performance test and reporting. So you can perform a standard PTC performance test, for example, and when you go into the software, you would select the dates and the times that the operator ran the test, and Performance Intelligence will tell you were the criteria met, and it actually lists each individual criteria. You can click into each one and see why it wasn't met, if it wasn't. And you can also, in addition to the standard PTC tests, you can develop your own testing criteria as well. And then you can download the report as an Excel file, just to click a button, download. So very fast report generation. And you can also see the previous performance tests side by side. So if I'm testing every 6 months and I want to see the last 4 and what the changes were, it's easy to see that in a singular view. So I think it's a great automation tool that's going to really increase productivity. And this came out of specific customer requests from multiple customers for this functionality. So what we're going to do when we look at future roadmap, say 2024, is really continue to focus on the user experience. I think that there is a ton of great functionality in the software, and now in the vein of continuous improvement, we're going to continue to look at how can we get the user from the point where they're seeing something initially to the point where they're seeing those detailed, that detailed data, et cetera, as quickly as possible. And how we're doing this is we're starting with, this product is co-developed with performance engineers in GE Vernova. And several of them have spent decades as performance engineers in power plants themselves. And so we're working with that team and our user experience team to develop some proposed changes, and then taking that to existing customers to get their input, because ultimately it's about the end user, but it's hard to approach people sometimes with a blank sheet of paper. And so we'll come with some proposed changes and then build off of that feedback from there.
That sounds like a great way to do it, to get some initial points and then focus and develop them from there. So at this point, we'll transition into the Q&A portion of the program. Thank you both, Janet and Aisha. That was really a great presentation, and you really answered a lot of good, or provided a lot of good information. I'd also like to point out to the audience that we have a couple of interactive features that you can download from the Handouts tab. So if you look on the platform, those handouts will be active now, and you can take a little bit of time before you leave the platform to download these interactive features that are available. They'll also be available on the website after the program in case you forget. We've had a number of questions come in, and so during the course of this portion, we'll answer as many that we can. Any that we don't get to due to time constraints, we'll answer via email after the program. So rest assured you will get an answer to your question. But to begin, let's get right into it. First question is, does this software also address reliability in addition to performance enhancements?
I can start on that. Yeah, I'll let you can fill in. So it's we have a separate product kind of under the same umbrella of reliability and performance that we call Reliability Plus or Smart Signal, that's really focused on reliability and availability. And I think that the two are very complementary to each other. Now, there may be some cases where performance intelligence would alert you to a performance issue that's also tied to an equipment issue that would cause reliability problems. But really the bulk of that predictive analytics for reliability is in that Reliability Plus product. And Aisha, I know you work closely with both, so feel free to add.
Yeah, so I think, I see a lot of value, especially customers that use, both of these solutions together. And we develop, templates with them that they can save, which, which help in, giving them additional value, right? So you have some recommendations from the performance side, and you can tie closely to the reliability side. And just one thing I'd like to add regarding the Reliability Plus, like Janet mentioned, it's an early warning detection system. So, it's really helping you in buying time to know when this equipment might fail, and you can, plan all the maintenance actions well in advance to avoid any downtime or surprises.
Okay, thank you both. What is the difference between this performance intelligence, PI, and software like ETA Pro?
Yeah, I think some of the things that I would note as differentiators, the alerts and diagnostics that we've discussed, that alerting capability that comes with a recommendation and really helps get to root cause faster. We have a couple of what we call economic advisors that Aisha and I have discussed a little bit, the offline water wash as well as inlet filter, that really shows you as a future prediction what's the optimal time to do this maintenance. And we have plans in the longer term roadmap to continue building out for additional equipment like condenser, HRSG, et cetera. I would also note the ability to be accurate at part load and detect issues at part load, especially if we're talking about GE equipment, because our performance model or our performance engineers also developed, helped design the equipment itself. And so there's certainly a higher level of accuracy there with GE equipment, though the solution is applicable across all OEMs. And lastly, I would say if you have APM, as we noted, this is integrated with the rest of your products. So it's an all-in-one, easy to operate. Aisha, anything that you would add?
I think you've covered it quite well, and the same point I'd like to emphasize is the accuracy on the part load. So since our models are physics-based thermodynamic models, we try to make them as accurate as possible through a range of operating loads. So, they won't be 100% accurate at part load, but they would be very close to those numbers.
Okay. Thank you. Next question is, what steps you are considering for the deployment of a predictive model?
I touched on that a little bit just in the last answer where I talked about the economic advisors. So those are forward-looking, and we do want to add more of those maintenance opportunities in addition to offline water wash and inlet filter. Otherwise, generally, performance intelligence is less predictive. That's more the functionality that you get from Reliability Plus, where they're doing that prediction and actually can predict oftentimes weeks or months into the future when there's a potential reliability issue that could come up down the road. So Aisha, anything else on that one?
Yeah, I think regarding the thermodynamic models, I think there's just one point I'd like to add, that we also are following industrial standards, ASME standards for the gas turbine, PDC 222, ST 6.2, and for the combined cycle 46. But as you mentioned, they're mostly, performance-based models rather than predictive.
All right. How much is scan time of this software?
Not sure I quite understand what they mean by scan time, Aisha.
Yeah, me neither. But I mean, if the question is how much of data are we feeding into these live models, uh, since these are, the prime agenda of this tool is to gauge performance, and as we know, performance doesn't really change every second, every minute. So our best practice is to kind of take an average of the last 5 to 7 minutes of data, which is coming in from your plant live, take an average of that. Some customers prefer taking the timestamp value, so it really depends on your preference. But we usually recommend to take an average of the last 5 to 6 minutes and feed them into the models. And like I mentioned, the best way to use the software is to understand the performance over a period of time rather than looking at it minute by minute.
Yeah, it's often more a longer term look, other than maybe when you're getting an alert of something that's been detected. And if for whoever asked the question, if we missed it, please feel free to reword and put in a little bit more detail.
Sure. And I know during your presentation you gave some examples, but this attendee would like, could you furnish a couple of instances where this software has effectively enhanced heat rate? Any specifics that you could give from past experience?
Yeah, but I can start. So I remember for one of the customers, they had a air cooled condenser on their site, and they noticed that their megawatt generation in particular, they were not meeting their targets. So using the different KPIs provided by the model, we started examining the different and parameters. And it turned out that they were not operating their ACC as per the, let's say, the performance curves of the condenser itself provided by the supplier. Now, since our models were based on these performance curves, right? So they were suggesting that this might be the issue, that you're not running the ACC fans in a very optimized way. So we did a bit of adjustment in our analysis. There is a tool called What If, which is kind of a digital twin where you can play around with the inputs, change the inputs here and there, ask the software to simulate the results, and you can get the results at different simulations, right? So we did some runs on 15 fans running, 14 fans running, 13 fans running, and through all these different scenarios, we were able to optimize the way they run their ACC, which helped them in reducing their auxiliary consumption as well. And they noticed an improvement, in their steam turbine generation as well. This is one example which just happened recently, so it's off my head.
Great. And I know we're coming up on the top of the hour. I would like to ask one more question. It says, is the SME essential for overseeing performance monitoring through the software? Do you feel, I mean, obviously it's going to be very helpful, and he's going to be able to provide a lot of great insight, but I am assuming you can train these plants to have an expert of their own that can really monitor this stuff. What would you say?
But I think someone with just a bit of knowledge about performance, someone who can differentiate performance from operations, right? Because it's not something that you would monitor minute by minute. I think someone with just basic background of thermodynamics, a mechanical engineer fresh out of college, who would be able to get maximum value out of this. And if it's an SME who's monitoring, that's an ideal situation.
Right. All right. Well, I want to respect everybody's time, but thank you both. I mean, I feel like this was really an informative session, and you provided great insight and answered some questions. We did not get to even half of the questions, so many of these will be answered via email after the session. I apologize for that. But again, I want to thank you both. I want to again thank GE Vernova for underwriting today's event, and thank everyone for attending. Aisha, do you have any last words you want to leave the audience with?
Well, thank you very much for listening to us, and we'll do our best to answer all the questions, and in case we're unable to, you know where to find us. So do let us know if you have any further questions.
And Janet, I'll give you a chance to leave some last words as well.
Yeah, I'll just second that. Thank you, and hope to get a chance to partner with you in the future and really bring a lot of value.
Okay. Well, thank you both. And again, thank you to all of the attendees. I hope you found the presentation beneficial, and I hope you have a great rest of your day.
Thanks.